Hi, welcome once more to Mr. Max. In this lesson, we are going to revise from September 2024 KwaZulu Natal Province probability questions. Okay, September 2024 KwaZulu Natal probability questions. So, I hope you are preparing for your examination. So, this is the last round preparation. So anyway, thank you for watching this channel. So those who didn't subscribe my channel, please subscribe my channel, like, share and comment. If you have any questions, you can ask me in as a comment, then I will reply for that. And also please share my channel with your friends. And thank you for watching once more. We can start. But before you start watching this one, please download the question paper from the description. I'll put a link there in the description. So you have to download the question paper, try to do by yourself. Then after that, you have to watch this one and check your answer is right or wrong. Okay. So anyway, without wasting time, let's start. Question number 10 and 11, that is probability. So we are going to revise probability section in this class. Okay. Look at question number 10, 10.1. During the COVID-19 pandemic, researchers conducted many studies to test the effectiveness of various vaccines. The table below shows the data of one of those studies. So there is a, you can see there is a table like this in that question paper. Okay. So what are the given things in the table? This is COVID positive and this one is COVID negative and this is a total. And what is this one? Males and females and also total. So you have to understand, you must get an idea of what is given in the table. So here, how many males COVID positive? 21. How many males COVID negative? 189. Total, how many males are there? 216. Total, how many females are there? 648. Total, how many people are have COVID positive? 108. How many people have COVID negative? 756. Like that. And overall total, how many people are there? 864. You understand? So you must get an idea of that table, then come back to this. A very simple question. First question, 10.1.1. What is that question? Calculate the probability that a randomly selected participant is a female. What is the probability of a randomly selected participant is a female? So probability of a female, randomly selected one is a female. That is a question. Simple question. Total, how many females are there? 648. Am I right? To overall total, how many? 864. So what is the probability? 648. That is the number of females divided by overall total. That is how you are supposed to write the probability. Am I right? So what is the overall total? 864. Check in your calculator. What is 648 divided by 864? 3/4. So the answer is 3/4. In your calculator, you will get 3/4. Now 10.1.2. What is that question? Is the probability of testing positive for COVID-19 independent of gender? Show all calculations to modify your answer. So what is the question? Is the probability of testing COVID-19 is independent of gender? So are they saying anything about a male or female? They are just saying gender, that's all. So it doesn't matter it's a male or a female. Do you understand, guys? Okay. So anyway, leave that question. Answer my question. How can we prove that two events A and B are independent? What is the condition for that you studied in your class? If two events A and B are independent, if you want to say like that, what you have to say? Probability of A intersection B is equal to probability of A times probability of B. Is not this one the condition for independency? Okay. So if two events A and B are said to be independent, means probability of A intersection B. Maybe in some schools, instead of A intersection, you wrote A and B, both are same thing. Okay. So probability of A and B is equal to probability of A times probability of B. Okay. So in this question, look at our question. Is the probability of testing COVID-19 is independent of gender? So there are two events there. One is COVID positive and the other one is gender. So doesn't matter, either you can take a male or a female to prove this one. because they are not specific that what gender, is it a male or a female. So here okay, for example, here I'm going to take a male as an example. If you don't like a male, you can take a female, no problem. Okay, so instead of this A, here it is what we can take a male. Okay, so male, and instead of this B, what is that one? COVID positive. COVID positive. So what is our event A here? Male. What is our event B? COVID positive. Okay, so how can we check two events are independent or not? It must satisfy this condition. Am I right? Okay, so here instead of this A and B, here it is male and COVID positive. So what we have to satisfy? We have to prove that this left hand side is equal to right hand side. That is how we are normally proving independent events. Am I right? So here how can we prove that one? Probability of, look at this one, male intersection COVID positive, and that one must be intersection and, okay, so that one must be equal to probability of male times probability of COVID positive. So if we can prove that this left side is equal to this right side, then we can say that COVID positive and gender is independent. Do you understand, guys? Okay, so listen once more from the beginning. This is a common question. This is many question paper I saw this type of questions. Okay, so listen once more. What is the condition to prove A and B are independent? Probability of A intersection B is equal to probability of A times probability of B. First you have to find this one, that answer. Then you have to find this one, that answer. If both the answers left side and right side are equal, then we can say it is independent. Okay, so in this question, instead of this A and B, they are asking male and COVID positive, not male, gender. So we just took a male, that's all. Okay, if you don't like male, you can take a female. Okay, so male and COVID positive. So how can we prove that? Probability of male intersection COVID positive. First you have to find that left side. Okay, then you have to find what is answer of this one. So if the left side and right side, if you are getting the same answer, then it is independent. Okay, now first I'm going to find this one. Okay, so probability of male intersection, or and, intersection is the same as and. Okay, intersection COVID positive. Probability of male intersection COVID positive. Male intersection COVID positive. So here male COVID positive, how many people are there? 27. Okay, so male intersection COVID positive means 27 people are there. Total how many are there? 864. So how can I write the answer of probability of this one? 27 over 864. Check in your calculator, what is the answer for that one? 27 over 864, 1 over 32. So the answer for that left hand side, this one, okay, is 1 over 32. Male intersection COVID positive, male COVID positive, how many? 27. Total how many? 864. So what is the probability? 27 over 864. Now we can find the right hand side. Okay, we are trying to find this one. Okay, so what is the right hand side? Probability of male, probability of male. Oh, we can find it together. Why should we waste time? Okay, probability of male times probability of COVID positive. We can find it together. Okay, so what is the probability of male? Total how many males are there? 216. How many people total? 864. So what is the probability of male? 200. Male is total is 216. So 216 divided by overall total is 864 times, this times is this one. Okay, probability of COVID positive. Total how many COVID positive? Don't think about male and female now. Total how many? Just COVID, probability of COVID positive. In this one, are they saying male COVID positive or something? No. Okay, just a probability of COVID positive. So how many are there? 108. So it is times 108. What is the overall total? 864. So now check in your calculator, what is the answer of that one? 216 divided by 864 times Another one, 108 divided by 864. Oh, there also you are getting the answer as 1 over 32. So what is the meaning of that? These two, left hand side and right hand side, we are getting the same answer, 1 over 32 and 1 over 32. What is the meaning of that? That two are equal. If it is equal, what is the meaning of that? It is independent. Okay, so next step we are going to write, it implies that probability of male intersection COVID positive is equal to probability of male times probability of COVID positive. So it implies that, so we prove that these two are equal. Okay, so what is the meaning of that? It implies that now the question, look at the question. Probability of testing positive for COVID-19 is independent of gender. So what we can write now, it implies that testing COVID positive, so let me erase this one. Testing COVID positive is independent of gender. Okay, so you have to write that comment. There is 1 mark for this one, is independent or is not independent. Okay, 1 mark is for that one. So we have to prove that left hand side and right hand side are equal, therefore it is independent. Okay, so that is 10.1.2. now let's move to the next question, question number 10.2. Question number 10.2. 10.2. What is that question? Towards the end of 2023, the KwaZulu Natal Traffic Department introduced a new number plate system for cars in the province. Okay, so they introduced a new number system for the cars. Each new number plate consists of 2 letters of the alphabet followed by 2 digits followed by 2 letters of the alphabet and ending with the ZN. Okay, so what is a new number system? These two are letters. Okay, then the next two are numbers, then again these two are letters, then there is a ZN. So that ZN, we don't have any choice, it must be there. ZN, KwaZulu Natal, that last in Eastern Cape EC, am I right? In Gauteng GP, am I right? Like that, that ZN is there, ZN is there, there is no excuse for that. So we don't want to even consider that one because the probability is 1 there, because we don't have any choice. What is the meaning of probability? Chances. Is there any chance for this ZN? There is no chance, it must be there, so ignore that one. Okay, now look at this one. What are these first two? Numbers, am I right? First two first two are letters, these two are letters, these two are numbers, and these two are again letters. Okay, now one example of such a number plate is RR23GB like that. Okay, first two letters, next two numbers, the next two again letters. Now all 26 letters of the alphabet excluding Q and 5 vowels. So there are some conditions for this one. Okay, they can't include any letter here, they can't include any letters here. Okay, so total how many letters are in the alphabet? 26. Okay, how many are vowels? 5. So 26 minus 5, that is 21. Okay, then there is one more, there must not be a Q also must not be there. Am I right? So one more minus. So total how many letters they can use? Only 20 letters. So look at that one. Total 26 letters. Vowels out. Then Q out. So total how many letters are out? 5 plus 1, 6 letters are out. So total how many letters they can use? 20 letters. Okay, so even though there are 26 letters in the alphabet, they can use only 20 letters. So don't forget, 20 letters they can use. Now what is the number condition? we used. Any two digits from 0 to 9 may be used. Okay, so there is no condition. 0 to 9, any numbers must they can use. Okay, no problem for that because it is in the middle. Okay, so any numbers from 0 to, so how many how many options in the number 0 to 9? Don't forget, not 1 to 9. 1 to 9 is 9, but 0 to 9 means how many options they have? 10 options. Okay, now what is the first question? 10.2.1. If these conditions satisfy, they are asking you, first question, how many different number plates can be made if the letters and the digits may be repeated? That one may be repeated. That is very important. So 1, 2, letter, number, letter. Okay, so I don't worry about that is sudden. Okay, so letter, number, letter. Okay, so look at that question. How many different number plates can be made if the letters and digits may be repeated? How many letters we can use? 20. So here how many options? 20 options. Am I right? Times letters may be repeated. So it means that here also they can use all that 20 letters. Am I right? Letters may be repeated means in case if they use A here, they can use that same A here also. Am I right? So there are 20 options here. Here also 20 options. Now, how many options for the numbers? 10 options. 0 to 9 means 10 options. Letters and numbers may be repeated. There is no problem to repeat the number also. So here 10 options, here also 10 options. Am I right? Letters and numbers can be repeated. Here letter. So here we have 20 option. Here also we have 20 option. Do you understand why it is like that? 20, 20, 20, 20 like that? Because letters and letters can be repeated. Why it is 10, 10? Because numbers can be repeated. Okay. So check in your calculator what is answer for that one. You must not leave it like that. It is 16, then it's a big number. Okay, so that many options they have. Okay, now next question, 10.2.1, I mean 2.2. What is that question? How many different number plates can be made if letters and digits may not be repeated? Underline that sentence, may not be repeated. So in this case, we are not allowed to repeat the letters, we are not allowed to repeat the numbers, and even also letters we are not allowed to repeat. Okay, so total how many letters we have? 20 letters. Total how many digits we have? 10 digits. So letters, there are 20 letters, and digits, there are 10 digits. Okay, and don't forget here letters and numbers are not allowed to repeat. Okay, so these two are letters, these two are numbers, these two are letters, and that is easy. Okay, easy we don't want, that is a permanent one. Okay, so for the first position, how many options we have? Is it not these two are letters? Okay, so these two are letters, these two are numbers, and again letters. So for the first position, how many letters we have in our pocket? 20 letters. Okay, so 20 options we have here. You understand? So don't forget here the letters are not allowed to repeat. So we already used one letter out of this 20 we used here. So total how many letters outstanding for this position? It's only 19. Am I right? So here there are 19 options. Okay, these are numbers, we can think about that one later. Is it not this one also letters? So how many letters we already used? Only 2 letters. Out of these 20 we used one here, we used one here, another one here. Okay, so out of this 20 how many letters we used? 2 letters. So how many outstanding now from this 20? 18. Am I right? So here how many options I have? 18 options. Now we already used 1, 2, 3 letters. So how many options how many letters outstanding? 20 minus 3, 70. Am I right? So here there are 17 letters. So letters finish. Now what is these two? Numbers. How many digits I have? 10. So for the first position, it is 10 options I have. I already used one number here. Out of this 10, I used one number here. Don't misunderstand that I used 10. 10 is a number. Don't think like that. Okay. Out of these 10 options, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2, 3, up to 9. Okay. 10 options I have. Out of that 10 options, I used any one number. Maybe it is a 5 or a 3 or a 2 or a 9 or 8 or whatever, maybe one number. So if I already used letters, digits may not be allowed to repeat. That means how many options I have here? 10 options here, but we used one here. So it means that for this position to be filled, I have only 9 options. You understand? So check in your calculator what is the answer of this one. These are the different options possible if the letters are letters and the digits are not allowed to repeat. So in your calculator, please check in your calculator. It is 10, 4, 6, 5, 2, 0. 10, 4, 6, 5, 2, 0. So these many options there. Okay. So that is question number 10.2.2. Now let's move to the next question, 10.2.3. 10.2.3. What is that question? If the letters and digits may not be repeated. So here in this question also, you are not allowed to repeat the letters or digits. If the letters and digits may not be repeated. Okay. Then what is the next sentence? What is the probability that a number plate of this form will start with the letters B and C in any order? Underline that sentence. Starts with the B and C in any order. So what is the meaning of that? The first two letters must be B and C. Doesn't matter in any order, what order it is. Okay. So now look at this one here. You must be very careful. First two letters, then the next two numbers. Again, it is two letters. Okay. So now in this question they are saying we have to find the probability. Okay, first let's find the numbers. Okay, in this question they are saying that the letters must start with B and C. Okay, so assume that here it is B and here it is C. Okay, we are forced to start with the letter B and C in any order. So what is the meaning of that, in any order? Excuse me. So in any order means it can be either like this, B or C. B, first letter is B, second letter is C. Okay, or what is the other option? Let me write it here. First two letters, then the next two numbers, then the next two again letters. So it can be like this also, guys. Look at this. First letter is C and the second letter is B. Am I right? In any B and C, they just want to start with B and C. Any order. So it doesn't matter first one is B, second one is C, or first one is C and second one is B. Okay. Now listen very carefully here. How many letters we have? How many letters we have? 20 letters. Am I right? Okay. And how many digits we have? 10 digits. Am I right? Okay. So from these 20 letters, we are forced to use this B. Am I right? Okay. We are forced to use this B. It means that we don't have any option. We are told that okay, you must have to use B here. So how many options I have? I don't have any options. I have only one option. I must use that B. Okay, there are 20 letters. Okay, fine. But somebody is telling me as okay, there are 20 letters, but you have to use B here. So it means that I have only one option. Am I right? Okay. Similarly, how many options I have here? Only one option, because I was told to put a C there. Do you understand? Okay. So here also I have only one option. Do you understand, guys? Okay. Now, anyway, from this 20, I used B, I used C. That means two letters already gone. We are not allowed to repeat the letters. Okay. So how many letters outstanding? 18. So for this position, how many options I have? 18. And how many options here I have? 17. Letters are not allowed to use because we already used two letters B and C here. Okay, so it means that from 22 already gone, so it is remaining is 18. Next one is 17. You understand? Okay, now look at this. I will explain this one later, or we can explain how many digits here. 10. We are not allowed to repeat. That means it is 10, and this one is 9. Okay, so now look at the second case. Here this is the first case. It can be B, C, or we can start with the C, B in any order. Am I right? Okay, here I was told to use C, so it means that I don't have any options. I must have to use C. That means 1. Am I right? Okay, and here I was told to use B, so it means that I don't have any option. Okay, even though 20 letters or 19 letters are there, okay, but I want to use that B. There is no other option for me, so it is 1. Okay, so from 20 letters I already used 2 letters, C and B. So how many outstanding from this 20? 18. So that I have to use here. And how many outstanding here? Letters are not allowed to repeat. That means the last one is 17. 18, 17. Okay, now here also it is how many numbers? Digits? 10. Digits are also not allowed to repeat. That means if it is 10 options here, next one is 9 options. Okay, so these are the two different cases. So what is the question now? You have to find the probability of this one. So how can I find the probability of this one? Look at that sentence once more. Find the, where is that? What is the probability that number plate of this form will start with so probability of number plate start with number plate start with B and C in any order. Probability of number plate starts with B and C in any order is equal to, so you have to multiply this one plus this option. There are two options we have. Okay, so it is 1 times 1 times 10 times 9 times 18 times 17 plus again 1 times 1 times 10 times 9 times 18 times 17, the whole divided by, if the letters are not repeated without any condition, what is the answer we got? 10 4 6 5 2 0 0. I don't use this one. This is another case. Letters are allowed, letters and digits are allowed to repeat. Okay, so in this question is based on not allowed to repeat. So total how many without any condition? Divided by 10 4 6 5 2 0. You understand? Okay, so why I am dividing with this number? Because here question is to find the probability. Probability means divided by total number. Am I right? Okay, so check in your calculator what is answer for this one. You can pause the video and try by yourself. 1 times 1 is the same. 1 times 10 times 9 times 18 times 17 plus again 1 times 10 times 9 times 18 times 17, that answer divided by 10465200, 1 over 190. So the answer is 1 divided by 190. You understand? Okay, so the same question you can do it like this without writing like this. Here we can write a 2, here B and C option, 2 times 1 times, directly you can find the answer also. Okay, 2 times B and C option here. So if you use B and C here, how many options I have? 2. Okay, so if I use B here, I'm not allowed to use B here. If I use C here, I'm not allowed to use C here. You understand? Okay, so like that 2 times 1 times you will get the same answer. Okay, so like that also you can understand, if you can understand. Okay, that is question number 10.2.3. now let's move to the next question, 10.3. okay, let's move to the next question number 10.3. 10.3, what is that question? Tracy has 10 seeds in a bag. Some are green and some are red. So how many seeds in a bag? 10 seeds. So Tracy has assumed that this is the bag Total how many sweets? 10 sweets. Okay, and some are green and some are red. Okay, so some are green, I don't know how many are green, and some are red. Okay, but anyway, total is what? 10. Okay, now some are green and some are red. She picks a sweet from the bag, takes note of the color, and then put it back into the bag. Underline that one. Put it back into the bag. So what is the experiment there? What she did? She took one ball. Is it a ball? Sweet. Sorry. She took one sweet. Check the color. Then put it back. You understand? That is the experiment. Okay, she took one without looking. She took one and checked the color, put it back. Okay, so now look at the next sentence. She does this 4 times. So how many times she did this one? 4 times. First, take the color, check the color, put it back. Again, take, check the color, put it back. Again, take, check the color, put it back. Again, take, check the color, put it back. How many times she did like that? 4 times. Do you understand? Okay, now how many green sweets are there in the bag? So you have to find how many green sweets are there, okay, in the bag, and how many green sweets are there in the bag. If the probability that she picks at least one green sweet is 97.44, that is a very important clue. Okay, so what is given there? Probability of taking at least one green. Probability of at least one green is 97.44 percentage. 97.44 percentage. So that is a very important clue. Okay, probability of at least one green is 97.44 percentage. Okay, so before I explain this one, you can pause the video and try to do by yourself. Okay, that's the way that you are supposed to study. Okay, so but before I explain this one, tell me, what is the total probability? Yeah, total probability is always 1. Am I right? Okay, if you toss a coin, what is the probability to get a head? How many options if I toss a coin? Head or tail? Am I right? Only 2 options. Okay, what is the probability to get a head? It is 1/2. Am I right? What is the probability to get a tail? 1/2. Just add these two. 1/2 plus 1/2. What is the answer? Is it not 1? So that is why we are saying that total probability is always 1. If you throw a die, okay, or dice, okay, what is the probability to get a number 1? 1/6. There are 6 options. Am I right? 1, 2, 3 up to 6. Okay, what is the probability to get a 2? 1/6. What is the probability to get a 3? 1/6. What is the probability to get a 4? 1/6. What is the probability to get a 5? 1/6. What is the probability to get a 6? 1/6. Just add. Is it not only 6 options there if you throw a dice? Am I right? Okay, so what is the answer for this one? If you add this one, you will get the answer as 1. So that is why we are saying that total probability is always 1. Okay, you have to remember that one, those who don't know that one. Okay, total probability is always 1. Now another thing, at least one green. What is the meaning of that word? At least one green. At least one green. So it means that either one green or more than one green. Here how many times they are taking? 4 times. Am I right? So at least one green means either one green or 2 green or 3 green or 4 green. It can't be how many greens? 0 green. Do you understand? At least one means either one. The least one is 1. It can't be 0 green or no green. Do you understand? Okay, so at least one green, that you have to clearly understand. At least one green means it can be 1 green, it can be 2 greens or 3 greens or 4 greens. Only one possibility is not, only one thing is not possible. What is that one? No green. That is not possible. Okay, so now I hope you understand that one. Okay, so at least one green means either one green or 2 green or 3 green or 4 green, not no green or not 0 green. Okay, now come back to our question. Now based on this one, so for to make my work easy, we have to find green, and what is the probability of one green is, at least one green is 97. Okay, what I'm going to do is I'm going to call the number of red balls as x. Okay, so I don't know this one, so it is x. Okay, so I just call the number of red balls. If you want to call green ball as x, no problem. Okay, so I'm going to call the red ball as x. So now how many green balls are there? Red ball, I call it a number of red balls, I call it as x. So is it not a 10 minus x number of red balls? Am I right? So now number of red ball is x. So what is the number of green balls? 10 minus x. It's not a simple concept. Okay, guys, so it's a very simple. Total is 10. Okay, red ball, let's say 5. I mean, let's say 6. Okay, then how many green balls? How can I find 10 minus 6? That is 4. Am I right? Similarly, 10 minus x, that is 10 minus x. Okay, so I called red ball as x and the green ball as 10 minus x. Now I'm going to draw a tree diagram. It is easy to find the answer based on a tree diagram, this type of questions. Okay, so how many times the experiment happened? 4 times. Am I right? So first time it can be a green ball or a red ball. Am I right? Okay, second one it can be a green ball or a red ball. Third one, sorry, it can be a green ball or red ball. So this is the first attempt. This is the second one. Then we are going to third one. It can be green or red, green or red. So green, red, green, red, green, red, green, red. How many times now? How many times in the question? 4 times. So first attempt, second attempt, third attempt. Now the fourth one. Okay, so it's a big tree graph. But we don't want to complete all of this one. I will explain now. Green, red, 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 green, red. Okay, so guys, after you finish this one, when you write your exam, it is not compulsory to write all this tree diagram. Okay, so anyway, now look at this question. Probability of at least one green is 97.44. Like what I said before, at least one green means either one green or no green. I mean, either one green or more than one green. Am I right? Okay. So here look at this one. Green, 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 green. 4 green. We have to take that one. Am I right? Okay. Then green, 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 red. There are 3 greens we have to take, because we have to take a 1 green, 2 green, 3 green, 4 green. Am I right? So we have to take this one, we have to take this one, then we have to take this one, 3 greens. We have to take this one, 3 greens. We have to take this one, we have to take this one, because there are 2 greens here. Then what, guys? We have to take this one, because green, green, green. Can you see? Okay, we have to take this one, red, green, red, red, because yeah, there is one green you can take. Am I right? Okay, sorry, I'm also confused here. Okay, then we can take this one, red, red, green, green, because there are 2 greens. Red, red, green, red. So 1 green it is we have to take. Red, 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 red. Is it possible to take this one? Red, 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 red. No, because there is no green there. Do you understand? This one, no green, no green, no green, no green. Am I right? All red color. So we are not allowed to take. So except from this one, all of this one is possible, because there is at least 1 green, 2 green, 3 green, 4 green. Am I right? Okay, so it is very difficult to write all that probability and add that one by one. Am I right, guys? It's too many branches here. Okay, so which one is not possible here? You just take that one. Which one is not possible? Is it not only this one is not possible because there is no green there? Do you understand, guys? Okay, so now look at this one. Probability of at least one green. So listen very carefully how I am going to write that one. Probability of at least one green, and I'm going to write it like this. Probability of at least one green is the same as 1 minus probability of no green. Listen very carefully. Probability of at least one green is equal to 1 minus probability of no green. From where do you get this one? That is the total. When you add all these probabilities, you are supposed to get the answer as 1. Am I right? Okay. So we have to find probability of at least one green. That is the same as the whole of this thing you add what is the total probability? 1 minus this probability R. Then what you are getting? This remaining. Listen once more. Listen. It's a simple concept, guys. What is the total probability when you add everything? Total probability is 1. Am I right? And what we have to find? Probability of at least one green. Is it not the whole of this thing is probability of at least one green? Total probability is 1, including this RR. Okay. So probability of at least one green means except this one, the remaining one. So how can we write that one? Total probability minus this one, probability of this one. That will give the remaining probability. Okay, so probability of at least one green is equal to 1 minus probability of not green. Okay, so it's almost similar as maybe you studied a complementary function. What is the probability of A complement? How can you write? 1 minus probability of A, something like that. You understand? Okay, so probability of at least one green is 1 minus probability of not green. Okay, so now look at this one. What is the probability to get a red? How many red balls are red sweets are there? X. So what is the probability? X over 10. So probability of this one is X over 10. Don't forget the sweets is going to put it back. So what is the probability to get again red? X over 10. Am I right? What is the probability to get again red? Sweets are going to put it back. So not change. So again it is X over 10. What is the probability to get this red? X over 10. So how can I find the probability of no green? X over 10 times X over 10 times X over 10 times X over 10. Okay. So look at how I'm going to write here. 1 minus X over 10 times X over 10 times X over 10 times X over 10. Is it not that one X over 10 the whole raised to 4? Okay, so that is 1 minus X over 10 the whole raised to, there are 4 extra over 10s. Am I right? Okay, now what is given in the question? Probability of at least one green is 97.44. Am I right? Okay, so now probability of at least one green. So look at this one. Is it not that this one probability of at least one green? And what is the answer given in the question? 97.44. Am I right? Okay, so let me write it here. So it means that 97.44 means 0.9744. Am I right? Divided by 100. Okay, and that is probability of at least one green is what we got, 1 minus this one. Okay, so it is 1 minus, sorry, no bracket, 1 minus X over 10, 1 minus X over 10 to the power of 4. Okay, now take this minus to this side and this 0.97 to the other side. So this minus on this side, it is positive X over 10 the whole to the power of 4 is equal to 1 minus 0.9744. Check in your calculator what is the answer of that one. x over 10 all to the power of, what is the answer for this one? If we can get the answer in fraction, it will be much easy. 1 minus 0.9744. Yeah, very good. 6. What is the answer in your calculator? 16 over 625. Okay. What is the power here? 4. So most probably this one also you can write it as a power of 4. Okay. So check, is it not 2 to the power of 4 is 16 and 5 to the power of 4 is 625. Okay. So look at how I am going to write that one. X over 10 the whole to the power of 4 is equal to 2 divided by 5 to the power of 4. You understand, guys? 2 to the power of 4 is 16. 5 to the power of 4 is 625. So it's fine. 16 over 625, we can write it like. What is the exponent here? 4. What is the exponent here? 4. Am I right? Okay. So so what we can write? We can equate the bases. So what we can write? X over, let me erase this part. Okay. So what is the answer there? X over, it implies that x over 10 is equal to, bases are equating, x over 10 is equal to 2 over 5. So cross multiply this 10, you can multiply to the numerator there. So what is that one? X is equal to 2 times 10 divided by 5. So x is equal to 20, 20 divided by 5 is 4. So the value of x is 4. What is x stands for? Number of red balls. But look at the question, what you have to find? How many green sweets are there? Not balls, sorry. What is x stands for? Number of red sweets. But the question is to find how many green sweets are there. So how many green sweets? We got the value of x as 4. So therefore number of green sweets, we have to find the green sweets, how many are there. Okay, so number of green sweets is equal to 10 minus 4, that is 6. How many green sweets are there? 6 green sweets. So look at this one, 6 plus 4 is 10 also. Okay, so that is the question. How many marks? Only 4 marks. Okay, so here when you write in your exam, don't waste your time to draw tree diagram, the full tree diagram. Okay, you have to understand, you have to think that, okay, probability of at least one green means you can't take any of that one. So that is the same as 1 minus probability of no green. Then take only that last branch like this, probability 1 minus probability of no green, then write it like this, then find the answer. That's enough. Okay. Okay, now I explained this one just for you to understand, but when you write your exam, you don't want to write all of that one, you won't get time. It's only 4 marks. Am I right? Okay, so you have to remember like this, probability of at least one green is 1 minus probability of no green. Okay, so when you get a similar question, you will remember, oh okay, we can do it like this quickly. Okay, so guys, that is KwaZulu Natal September 2024 probability section. I hope you understand clearly. Thank you for watching. Keep on watching, practice maximum number of questions, and at the same time, those who didn't subscribe, I saw that many of you watched and didn't subscribe, so please subscribe my channel. Like, if you like my channel, please like, share with your friends, and also if you have any comments, please comment, then I will reply for that. Anyway, thank you very much. See you on the next lesson. Thank you. Bye.